Hello students, in this lecture we will see one more numerical on Supermesh Analysis. Now the problem statement is determine the power delivered by the voltage source and the current in the 10 ohm resistor of the network shown. So power delivered they are asking by the voltage source. So power is nothing but voltage into current. So basically we have to calculate current flowing through this branch or through this voltage source. So there are three meshes. So we'll assume three currents. So this is I1. Here I am the second mesh I am assuming I2, and here I am assuming current as I3. So can you apply KVL in mesh 1? No, you can't apply KVL in mesh 1 because there is a current source. So 3 ampere is shared between mesh 1 and mesh 2. So they are forming one super mesh. Can you apply KVL in mesh 3? No, you can't apply KVL in mesh 3 because there is a 10 ampere source in the outer part of this mesh. This is not the shared one. So you can write from mesh 3. You can directly write down I3 is equal to, I3 is moving downward. So this is 10 ampere. No need to assign the sign over here. I3 is 10 ampere. So now we'll go for super mesh analysis. So here I am writing super mesh analysis. And the first part you get, or rather the super mesh is formed because of mesh 1 and 2. So by looking at the direction of current source, and the current source which is 3 ampere is shared between mesh 1 and 2, it is moving downward. So I have to write down net downward current through this branch, okay, through this branch. So here that current is nothing but I1 minus I2. So in equation format, this will give me 1I1 minus 1I2 plus 0 I3 is equal to 3. And this is my equation number 1. Now the second part I will get by, in the supermesh analysis, I will get by applying KVL to supermesh. So the path is will be 55, then this 5, then this 10, 1, and then you have completed this path. So this is the KVL, how you are going to apply in supermesh. So I will write over here KVL to supermesh. So here I will have positive, negative, positive, negative. Here I will have positive, negative, positive, and negative. So I'm starting at this point 50. KVL means every quantity should be voltage. Minus 5 times I1. Go ahead. Minus 5 times I2. Go ahead. Minus 10 times I2 minus I3. We are moving towards left through 10 ohm. So the I2 minus I3. Minus 1 time I1 minus I3. And then you have completed this thing. So this is equal to 0. Whenever you have a shared resistance, be careful about these terms. General student write minus 10 times I2 minus 1 times I1. No, it is not like that. Whenever you have a shared resistance, you have to take the net current flowing in the direction of the KV. Okay, so 50 minus 5I1 minus 5I2 minus 10I2 plus 10I3 minus 1I1 plus 1I3 is equal to 0. So minus 5I1 minus 1I1, this will give me minus 6 times I1, minus 10I2 minus 5I2, I will get minus 15 times I2, and only one term, no, plus 11I3. These two terms are there, this one and this one. So it will give 11I3, and this is equal to minus 50. This is my equation number 2. And now equation number 3 I have already obtained. Here this can be written as 0I1, 0I2, 1 time I3 is equal to 10, and this is my equation number 3. So I will enter these coefficients and constant of equation number 1, 2, 3 in calculator, and I will calculate I1, I2 and I3. So I1 turns out to be 9.76 ampere, I2 turns out to be 6.76 ampere, and I3 is 10 ampere. The problem is not over yet. They are saying power delivered by the voltage source. So power delivered by this voltage source. Voltage source value is 50 volts. So 50 volt is the suffix over here. The power is P. So power is nothing but voltage into current. So 50 volt, and the current through this one is I1. So here multiply by I1. So that is 150 into 9.76, and this will give me answer as 488 watt. So this part is over. Now we have to calculate current through 10 ohm resistors, and the 10 ohm resistor is over here. So here I am writing current through 10 ohm resistor. Okay. Now you decide how you are moving, towards right or left. Don't look at this polarity. Okay, you have to write in terms of current. If you are moving, decide to move towards left, then it will be I2 minus I3. I2 minus I3 towards left. So that will give me 6.76 minus 10, and again leftward, and this will give me minus 3.24 ampere towards left, which means I will write over here 3.24 ampere towards right. So both the things we have calculated. Be careful about the current through this resistance. We do not look at this polarity. So that is all about this numerical on super mesh. Thank you.